This video is on polynomials. We're going to do some polynomial operations. Operations are to add, subtract, multiply, divide. So we're going to look at adding, subtracting, and multiplying. You can only add and subtract like terms. They must have the same variables and exponents. X and x squared are not the same term because even though they have the same variable, they do not have the same exponents. So an example that we can add together would be 2a to the third and 5a to the third, because these have the same variable and the same exponent. That means that we would just add the 2 and the 5 together, and then we would have 7a cubes. Another example would be 4x to the 7th y and x to the 7th y. Because these have the same variables of x, y, and x to the 7th is x to the 7th, we get to put our 4 and our 1 together. Even though you don't see a number here, there is one of them here. Another example that we could put together is -4 and 10. Because -4 and 10 have no variables with it, so these are just constants, so we can always combine these because they are like terms. We combine like terms by adding the coefficients, and we keep the exponents on the variables. So the coefficients we're going to add together, so the 4 and the 1 would add together, but everything with the variables will stay the same. So the exponents on the variables will stay the same. This would become a 5, 4 plus 1 is 5, x to the 7th y. This term would become 5 plus 2 is 7, a cubed, because we would not do anything with the exponents. Combining them means we could either add or subtract, so we would just be combining them like we would normally do normal numbers. Now with multiplication, you can multiply anything together. You just have to make sure to distribute. So when you distribute, you multiply the coefficients. So we would multiply the actual number, so 5 times 2. And we would add the exponents together of the same variables. So it would be x to the 5th and x to the 4th would become x to the 9th because we would add them. So we're going to use polynomial operations. Use the correct operation. We're going to simplify it completely. We're going to classify it by degree and number of terms. So when we put them into the correct format, we can then classify them with the degree and number of terms. So the first thing we look at is what operation is happening. We are adding these two problems, so we're not multiplying anything. We have a positive value in front of this first set of parentheses, so I'm going to just rewrite this as -2x minus 9. We have a positive in front of this set of parentheses, so everything inside the parentheses stays the same. So I'm going to have a positive x and a positive 4. Now I can determine which pieces are my like terms. I have the variable x with an exponent of 1, and I have a variable x with an exponent of 1. I can combine these two pieces together. I can also combine, I have a -9, which is just a constant, and I have a 4, which is just a constant. I can combine these two pieces together. When I combine them, I get -2x and a positive x. That is a -1x. Because I just add the coefficients, -2 plus +1, and I keep the x the same. -9 plus 4 becomes a -5. This is now in standard form because I have my largest exponent first. My largest exponent has an exponent of 1, so this is a linear. And now that it's in standard form, I've simplified it completely. It has 1, 2 terms, which is called a binomial. So the entire answer for this problem is it's simplified to negative 1x minus 5, and it's called a linear binomial. Question 2, again we look to see what operation is happening between the parentheses, and we have addition. The term, so that means we're not multiplying anything, we're just combining our like terms. In front of our first set of parentheses we have a positive, so I'm going to rewrite this as positive 3x squared minus 2x plus 1. Everything stays the same. In front of our second set, we have a plus sign, so that means everything stays the same. So we have a positive 6x squared, and we have a positive 3x. Now to determine what can go together. So we look for our largest exponent, which here we have a 2, and we have another 2. So no other exponent is higher than 2. We have a 3x squared and a positive 6x squared that can go together. Then we look for the next exponent, down from 2 would be 1. We have a negative 2x that has an exponent of 1. And then we have another 3x, which has an exponent of 1. And then lastly, we have a constant of 1, and there's nothing else that goes with that. So now that we have all of our terms recognized, let's put them together. 3x squared and positive 6x squared go together, and those have the largest exponent, so those are the ones we're doing first. 3 plus 6 gives us 9, and we keep our x squared as is. Then we have the negative 2x and the positive 3x, so that becomes negative 2 plus 3 is a positive 1. So we have a positive 1x. Then we have the constant, which goes with nothing else, so it's positive 1. Now that we have it in standard form, we've simplified it completely. We can now call it by its name. The highest exponent is a 2, which is called a quadratic. And it has 1, 2, 3 terms. So that's called a trinomial. So our final answer is 9x squared plus 1x plus 1, and it's a quadratic trinomial. On the next problem, we again look to see what operation is happening in between the parentheses. We have a plus sign. That means we're adding them. We're not multiplying. So we're going to rewrite this without the parentheses. We have a positive in front of our parentheses, so everything inside stays the same. So we have a 6x cubed minus 12x plus 1. We have a positive in front of our second set, which means everything stays the same. We have a positive 8x squared, a positive 10x, and a negative 6. Now to start comparing them and seeing which terms are the same, we look for our largest exponent. We have an exponent of 3, and that's our largest exponent. So that's going to be our first piece, and there is no other exponent that has a 3 with it, so that means that that will be by itself. Next, we go from 3 down to 2. We have an exponent of 2 here, and nothing else goes with that, so that will also be by itself. Next, we look for an exponent of 1, so just a basic x. We have a negative 12x here, and we also have a 10x here. Then we look for any constants or anything left over. We have a positive 1 here, and we have a negative 6 here. So now that we have them all classified or all distinguished, we can put them together. We look for the highest exponent, which was our 6x cubed, and nothing went with it. So we're going to keep our positive 6x cubed. Next, we go to our x squared, which had no other term that went with it. That was a positive 8x squared. Then we looked at our x's, which is a negative 12x and a positive 10x. So we add those. That becomes a negative 2, and we keep the letter x. Then we go to our constants, which are 1 and negative 6, which gives us a negative 5. Now that it is in standard form, we look at our largest exponent, which is 3. This is called a cubic. And then we count how many terms there are. We have 1, 2, 3, 4 terms. So this is called a polynomial of 4 terms. because it does not have any special name to it like a binomial or a trinomial. So we have 6x cubed plus 8x squared minus 2x minus 5, which is a cubic polynomial of 4 terms. On the next problem, we again look to see what's happening between the two sets of parentheses, which is a subtraction sign. So we're not going to be multiplying the variables together. So let's rewrite this. We have a positive sign in front of our first set of parentheses, so everything stays the same. So we have 7x plus 10. We have a negative sign in front of the next one, so that means that all of these signs change. That means that we have a positive 3x, which turns into a negative 3x. We have a negative 8, which turns into a positive 8. Because what is happening here is you are in fact distributing only the negative sign, the negative 1. So when we get rid of that negative, it goes to each of these, it distributes to each of those, and all the parentheses go away. So now that the parentheses are gone, we can put our like terms together. Look for the one with the largest exponent, which we have an exponent of 1 and nothing larger. So our 7x can go with our negative 3x. Then we look for constants. So then we have a positive 10 right here, and we have a positive 8 right there. So now we can combine our like terms. Our 7x goes with our negative 3x, which gives us a positive 4x. And we have a positive 10 and a positive 8, which gives us a positive 18. It's in standard form. Our largest exponent is a 1, which tells us that this is a linear. And there are 1, 2 terms, so this is a linear binomial. So our final answer is 4x plus 18, which is a linear binomial. On question 5, we look between the parentheses, and this is a subtraction sign again. So we will distribute the negative, which will just change the signs inside of our parentheses. We will not multiply variables together. So let's just rewrite this without the parentheses. There is a positive in front of our first set. That means all of the things in here will stay the same. So we have a positive 5x squared, a positive 3x, and a positive 8. The negative in front of the second set changes all of the signs inside of this set. So positive 2x squared turns into a negative 2x squared. A negative 2x turns into a positive 2x. And a negative 9 turns into a positive 9. Again, it's because you are distributing, you're multiplying by a negative. Now let's start combining our terms. We look for the largest exponent, which we have an exponent of 2 and nothing higher. So we have 5x squared can go along with negative 2x squared. Next, we want to look for the exponent of 1, which we have a positive 3x, which goes along with positive 2x. And then we would look for our constants. We have a positive 8 and a positive 9. So we go with 5x squared and negative 2x squared, which is a positive 3x squared. Then we have our linear part, our 3x, positive 3x, and positive 2x, which give us a positive 5x. Then we have our constants, a positive 8 and a positive 9, which give us a positive 17. Now that it's simplified, it is in standard form. Our largest exponent is 2, which is a quadratic. And there are 1, 2, 3 terms, so it is a trinomial. So we have 3x squared plus 5x plus 17, which is a quadratic trinomial. On this next problem, we again look in the middle to see what's happening between the parentheses. It's subtraction. So we're not going to multiply any variables. We're just going to rewrite this. We have a positive sign in front of our first set of parentheses, so we're going to rewrite everything as it is. We have a positive 4x cubed. We have a positive x squared, a negative 9x, and a negative 8. This negative sign in front of the next set means that all of the signs just change. So our 7x turns into a negative 7x cubed. Then this turns into a negative 2x. And our 6 turns into a negative 6. So we look for our highest exponent, which we have a cube here. And nothing is higher than a 3 as the exponent. So we have 4x cubed and a negative 7x cubed. Then we'll look for squares. We have a positive x squared, And that's the only one that we have for that. Then we look for our x's. We have a negative 9x and then a negative 2x. And then we look for constants. We have a negative 8 and then a negative 6. So let's combine them. Our x cubed, we have 4x cubed and negative 7x cubed, which gives us a negative 3x cubed. Then our squares, we have 1x squared right here, so that's all we have is positive x squared. Then we look for our x's. We have negative 9x and negative 2x, which gives us a negative 11x. Then we look at our constants. Negative 8 and negative 16 give us a negative 14. So now we have the highest exponent is 3, which is called a cubic. And there are 1, 2, 3, 4 terms, so this would be called a polynomial of 4 terms. So our answer here, negative 3x cubed plus x squared minus 11x minus 14, is a cubic polynomial of 4 terms. On question 7, we look to see what's in between the parentheses, and there's no operation that we see. This is multiplication. So this time we are multiplying because we can put a little dot in there saying this is multiplication. Now there are a couple of ways to multiply terms. I'm going to show one method for this problem and then a different method on different problems. I'm going to call this method the box method, which I'm multiplying all of the x plus 2 times all of the x plus 5. It's the area model. Box method is basically the area model. So I'm going to make this the top of my box, so my width of my box, and I'll make my x plus 5 the length of my box. So I have an x and a positive 2 for my top of my box, and I have an x and a positive 5 for the side of my box. So what we're going to do is multiply and do the area of it. So this is going to be x times x because this is the length and this is the width of my box. X times x is x squared. On my next piece of my box, this is a length of 2 and a width of x because this is the same width here. So this is really 2 times x. 2 times x is 2x. On this box, this is the width of x right here because it's the same as this top part. This is an x times a positive 5. So this is an x times a positive 5, which is 5x. This last box is the same width as a positive 2, and this is the same length as this positive 5. So this is really a 2 times the 5. Positive 2 times a positive 5, which is a positive 10. So now that I have them all multiplied, we can combine our like terms. I have 1x squared here and no other x squareds. I have a 2x and a 5x, which means I can combine those, and I have a constant of 10. So I can have an x squared, then I have a 2x and a 5x, so that becomes a positive 7x. And then I have a constant of 10, which was a positive 10. So when I distribute this, this is x plus 2 times x plus 5, gives us an x squared plus 7x plus 10. This has a largest exponent of 2, so this is a quadratic. And there's 1, 2, 3 terms, so it's a quadratic trinomial. This is just one way of multiplying it. This is how you could see area models by length times width. Now I'll show another way of multiplying as well. On number 8, there is a difference. We only see one set of parentheses, but it's squared. When you see a parentheses squared, squared means it's multiplied by itself. So you actually write that x minus 5 twice because it's squared. So you write it as x minus 5 times x minus 5. Because 5 squared, if we were just thinking of it as a basic 5 squared, that would be called 5 times 5. You don't distribute the exponent, you have to actually write it twice. So now I could use the box method, but I'm going to show a different way of multiplying. I'm going to distribute. So I'm going to focus on pieces of it. I need to take this x, I need to multiply it to everything on the other side of the parentheses. So I need to take this x and multiply it to that x, and I need to take the x and multiply it to that negative 5. So when I multiply, I'm getting rid of the parentheses. So my x times x becomes x squared, and my x times negative 5 becomes a negative 5x. So I've multiplied the x to everything, but that's not the only thing inside this parentheses. I also need to multiply my negative 5 to the same pieces. So I multiply negative 5 to the x and negative 5 to the negative 5. Again, when we distribute, we are getting rid of the parentheses because we're multiplying through the parentheses. Negative 5 times x is negative 5x, and negative 5 times negative 5 is a positive 25. Now we can combine our like terms. So again, we look for our largest exponent, which is x squared. There are no other x squareds. Next, we look for our x's. We have a negative 5x and another negative 5x. Then we look for our constants, which we have a positive 25. So we have an x squared, negative 5x, and negative 5x give us a negative 10x. Be careful on that. Make sure that you are combining correctly. And then we have a positive 25. This is a x squared is a quadratic. And there are 1, 2, 3 terms, so it is a quadratic trinomial. To distribute means you take everything from the first set of parentheses and multiply to everything in the next set. So on question 9, I'm also going to distribute again. Because if we look in between the parentheses, there's no operation, there's no addition or subtraction in between, so it is a multiplication. Now, because there is a coefficient out front, and then we have a parentheses and then another parentheses, we actually have 3 pieces that are being multiplied instead of just 2. We can actually multiply any 2 at a time. So we can multiply the 2 sets of parentheses first, or we can multiply the 4 times the first set of parentheses, or the 4 times the second set. We cannot do the 4 to both sets. That's 3 things. So you can only take 2 at once. So what I'll do is I'll just take the first 2, the 4 times the x minus 1. I'll multiply that. I will distribute the 4 into only the first set of parentheses. That becomes 4x minus 4. Now I kept this inside the parentheses because I still need to multiply it to my second set. That is why I kept the parentheses with it. Even though I multiplied over the parentheses, I want to keep them in because I have an extra set later. All of this is being multiplied to the 2x plus 3. So now I need to distribute. So I've distributed the first 2. Now I can distribute my new set to my second set. Again, I'm multiplying 2 sets at one time. So I want to distribute. I'm going to take my 4x times my 2x. I get positive 8x squared, because when we multiply variables, we add the exponents. So that's the exponent of 1 and an exponent of 1. 1 plus 1 is 2. I take my 4x and I multiply it to my positive 3, and we get a positive 12x. Now I've multiplied my 4x to everything, so I come to my negative 4. Have to do the same thing. Negative 4 times 2x is negative 8x. And then we take our negative 4 and multiply it to our positive 3, which gives us a negative 12. We've distributed every piece of this first set into the second, and we've gotten rid of all the parentheses. Now we combine our like terms. We have an 8x squared with nothing else with it, so it goes with an 8x squared. We put our 12x and our negative 8x together, which is a positive 4x. Then our negative 12 has nothing to combine with it, so we have minus 12. This, again, is a quadratic because the exponent is 2. So we have a quadratic, and we have 1, 2, 3 terms. So it is a quadratic trinomial. it is important that you only multiply two things at a time. So when I multiplied the 4, I only multiplied it into the x minus 1. I did not multiply it into everything. So please be careful when you distribute.